Hi everyone, I'm trying to start my video. Just wait for Handika to make me the host again so that I can start my video. Yeah, Handika. All right. So if Handika can stop sharing the screen, then I can start this webinar. Hello, good morning, good afternoon, everyone. Everyone can hear me and see me okay? Mantap, great. So, good morning again. So everyone, thank you for joining. All participants, the panelists, the chair. It's great to be with you here today in today's CAIPSDCC webinar, which will discuss about the impacts and on ecosystem and biophysics in small islands from pandemics and climate crisis. So thank you very much for those of you who have registered to our event. We have more than 1,100 registered participants. It is more than the capacity of the Zoom account that we have. So our sincere apology for those who can't enter the Zoom room. Hence, we also set up a live stream option via YouTube. Hello all who watch this from YouTube. I hope it's already alive. So Handika, please check. So you can all say hi to each other by writing down your name, your organization, and which city you are from in the chat box so that we can know where you're coming from. I'm Lia Zakia, the program coordinator of CAIPSDCC, and CAIPSDCC is a collaborative Australia-Indonesia program on sustainable development and climate change. It is a collaboration between Griffith University Australia and Universitas Indonesia, along with some other universities in Indonesia, such as Universitas Hasanuddin in Makassar. The collaboration has several components. The first component is a research collaboration on climate change and sustainable development. We focus on the 4 themes, which are impacts of climate change on planetary and human health, sustainable landscape management, energy transition and carbon pricing, and increasing the resilience of small islands in eastern Indonesia. This research collaboration components aims at enhancing the science to policy principle. Therefore, we have included various stakeholders to the research, such as national and local government, private sectors, NGOs, and communities. The second component is the capacity building. The third component is student mobility between Australia and Indonesia, which is a bit tricky at the moment. The fourth one is the high-level dialogue and a series of webinars. Today's event is under this component. So now I would like to move to the housekeeping rules or to the logistical aspect of this webinar so that we can all have enjoyable session and have a meaningful discussion. The participants don't have to fill in any attendance list. We will have attendance report from Zoom, so you can just focus on the materials. You can write down your questions in the Q&A box, not the chat, the Q&A box, so that we can notice your questions. We usually receive a lot of questions. It is challenging for us to answer all, but we will do our best. Make sure that you read the existing questions first before you write down your own, just in case it has similarity with yours. Then you can just upvote it by clicking the thumbs up icon. For YouTube viewers, you can also write down your questions, so don't worry. Our team will move it to the Q&A box here in the Zoom to ensure that it can be seen by other participants at Zoom to be upvoted. The chair will focus on the most popular questions with the most upvotes or the most relevant to the discussion at that moment. The presentation materials can be downloaded in our Google Drive account, and then we will share the link at the end of this webinar. Information about the request for certificates will be shared in the end of the webinar, so stay tuned. So we also have the poll here. We have some questions over there. It would be great if all participants can fill that poll, and then later we can share the result. Before we start the discussion, let's hear the opening remarks from Ibu Amanda Katili Node. She is the manager of the Climate Reality Project Indonesia, part of a global organization that mainstreams the climate crisis and its solutions and actions. She previously had a position as the head of expert team at the Office of the President's Special Envoy for Climate Change in Indonesia. And she is also, she received the degree from Institute Teknologi Bandung in Indonesia. And then she completed the PhD from the, it's missing, from University of Michigan, Ann Arbor, USA. She also completed an executive leadership program at Georgetown University and Yale University, USA, and received a prestigious award as a resident policy fellow at the Rockefeller Foundation's Bellagio Center in Italy. So, ladies and gentlemen, please join me to welcome Ibu Amanda. Yay! Ibu, silakan.
Good morning, good afternoon, good evening to those who have tuned in. His Excellency, Professor Rahmat Witular, who is joining from the YouTube channel, Professor Caitlin Byrne from Griffith Asia Institute, and Professor Yatna Supriyatna, Universitas Indonesia, our esteemed panelists, my colleague, Andreas Hutahaean, Ph.D., Coordinating Ministry for Maritime and Investment Affairs, Dr. Augie Shahai Latua from the Indonesian Institute of Sciences, Dr. Guillermo Diaz Pulido, Griffith University, our session chair, Dr. Intan Suci Nurhayati, Indonesian Institute of Sciences, distinguished participants from a number of countries. As Leah said, I'm Amanda Katiliniode, Manager of Climate Reality Indonesia, and I'm also honored to be a member of the advisory board for the collaborative Australia-Indonesia programs on sustainable development and climate change. I'm very grateful to be here, meeting with all of you digitally. And on behalf of CAIPSDCC, again, I'm honored to open this webinar that will discuss the impacts on ecosystem and other biophysical processes in small islands from the pandemics and the global climate crisis. This is part of our weekly webinar under the framework of CAIPSDCC, organized by Universitas Indonesia and Griffith University, Australia. In this current pandemic situation, it is time for us to reflect and rethink about better ways to move forward. We have to leave our old ways of doing things. We have to integrate climate mitigation and adaptation into the recovery process from this pandemic through active global collaboration based on science. Distinguished participants, CAIPSDCC aims to expand our contribution to climate actions and sustainable development by collaborating with other education institutions on research and innovation, capacity building, student mobility, and science to policy dialogues. Together with partners from Universitas Indonesia, Griffith University Australia, Universitas Hasanuddin, and also a number of stakeholders representing NGOs and businesses, we support activities on climate change and sustainable development with the goal of communications and engagements. We also work to develop policy briefs based on data and scientific facts. Digital distinguished participants. In terms of data and facts, I would like to share good news from the Climate Reality Project, which some of you may have read in the news. Our founder and chairman, former Vice President Al Gore, and an international coalition of technology and nonprofit organizations just launched a new project. The Climate Trace Coalition is building the world's first global, verifiable, and comprehensive greenhouse gas emissions tracking tool. So it's Climate Trace, and Trace stands for Tracking Real-Time Atmospheric Carbon Emissions. The tool will use satellites, ground and sea-based sensors, and multiple data streams combined with artificial intelligence and machine learning to track in near real time the sources of human-caused emissions globally with unprecedented granularity. The goal is a public release of emissions data in the summer of 2021 ahead of the COP26 negotiations later that year. The tool has the potential to support countries' emission reduction progress toward Paris commitments. And it will also inform public sector policy making and private sector investment, also empower citizens and civil society, and give polluters no place to hide. Ladies and gentlemen, in closing, I heartily thank all the participants for the enthusiasm in joining this webinar. I hope we all can unlearn and relearn important lessons and find ways to take stronger actions towards the fight against the global climate crisis.
Thank you very much, Bu Amanda. Please give a round of applause for Bu Amanda. So even though we are now doing it online, we still have to keep the spirit up. So ladies and gentlemen, I've already launched the poll. So if you please participate in our poll, that would be great so that later we can share the result and discuss it. Next, I think I am ready to introduce our wonderful chair for today, Dr. Intan Suci Nurhati. She received her Ph.D. in 2010 from the Georgia Institute of Technology, USA, majored in Earth and Atmospheric Sciences with certificate in Environmental Public Policy. She dedicates her research to investigate anthropogenic signatures on climate and marine environmental changes in the Indo-Pacific region over the past centuries to millennia using natural archives. She is a permanent scientist in the Indonesian Institute of Sciences from 2016 until present. She also serves as lead and contributing author of the 6th assessment report of IPCC, Intergovernmental Panel on Climate Change. Ladies and gentlemen, please join me to welcome Dr. Intan. Dr. Intan, monggo.
Hello, thank you, Mbak Lia. Good morning, everyone. And welcome to all the excellent speakers who are joining us today. They are joining from home, some from the office, and even one person from the airport. So thank you for being here with all of us today. So our speakers today will enrich your understanding on how the climate crisis and the pandemic impact small islands ecosystems, particularly in Eastern Indonesia. And we're also looking forward to having a lively discussion with all of you who are joining us in YouTube as well as the Zoom. All right, so my name is Intan. I will be your host for today. So let me start our conversations today on two different, but not so different climate crisis, global crisis that we are currently facing as a society. So we are facing climate change and the pandemic. Climate change is real, and it is a global crisis affecting modern society in all parts of the world. And the COVID-19 pandemic is a global crisis affecting health of many people in the world. So these two global crises, if we think about this, they're different in terms of their time of emergence. On one hand, we have global climate crisis that has been happening since the beginning of the industrial era. So our planet has been warming, our glacier has been melting, our oceans has been changing for many, many decades now. While on the other hand, we have the pandemic, which come just suddenly out of the blue. And the last time we actually have something similar to this was more than 100 years ago during the 1918 Spanish flu pandemic. And the society was much different back then compared to today. But let me also highlight that these two global crises have something in common. They do. That is, early actions do save people's life. We need early actions to combat these two crises. So while we are adapting to the pandemic, the new normal, which is not easy, it is important that we keep our eyes to keep up our momentum with adaptation and mitigations of climate change while we are facing the pandemic as well. And this is particularly important for Indonesia as a maritime nation because we are super rich in biodiversity, particularly in Eastern Indonesia. So with that in mind, today we have three excellent speakers who will give triggering 10-minute talks about these issues. First, we have Dr. Andreas Hutahaean from the Coordinating Ministry for Maritime and Investment Affairs of Indonesia, followed by Dr. Augisa Hailatua from the Indonesian Institute of Sciences, and Dr. Guillermo Diaz-Pulido from the School of Environment and Science at Griffith University. Before we give the floor to Dr. Andreas Hutahaean. Let me read his brief biography. Dr. Hutahaean is currently working as Deputy Director for Marine Conservation and Small Island Utilization at the Coordinating Ministry for Maritime and Investment Affairs of Indonesia. His study and career has been driven by a strong interest in ocean and people, with more than 17 years of experience, including at the Max Planck Institute for Marine Microbiology, Marine Geology Department at the University of Bremen in Germany. Dr. Hutahaean has expertise in blue carbon, ocean climate change, and blue economy. He finished his Ph.D. from the University of Nagoya, Japan, on marine biogeochemistry. He's also a lecturer at the Marine Science Postgraduate Program of the IPB. He is one of the pioneers in developing Indonesia Blue Carbon Program and also a negotiator for oceans in the UNFCCC meetings. So with that introductions, I will give the floor to Dr. Hutahaean, who is actually joining us from the airport before he's catching his flight. So, Pak Andreas.
Thank you, Bu Intan. Can you hear me?
Yes, I can.
Yeah, but I'm sorry. It seems like my camera. Okay. Thank you. Now it's on. I would like to give you share some information regarding. It is very difficult at the moment if we are talking about the something happened in the different time scale. Something like what happened in our climate change, and suddenly we have a pandemic, which is also influenced to our climate system, and what is going on the glass floor at its mean in the coastal ecosystem. So I'm trying now to make some information regarding how the rules of the coastal vegetation, focusing on the mangrove and seagrass ecosystem in Indonesia for mitigating our climate change. And I will give some example, not only from the big land, big island, something like Jakarta, Java or Kalimantan, but also some study conducting in the several small islands in Indonesia as example, how is the different ecosystem between small islands and then big islands. I think most of us know about Indonesia is, I think this is just a brief geographical condition about Indonesia, mentioned that we have about 70% our territory covered by marine. So it's about 5.8 million kilometers square. And we have also more than 17,000 islands. It means maybe 95% of the 17,000 islands is small islands. So this is a big task for this kind of webinar to identify, to learn about what is going on the small islands in Indonesia. So let's starting about what is the important thing for our coastal marine ecosystem for adaptation and mitigation climate change. I think we know that some important aspect in our coastal ecosystem is the adaptation. Adaptation means they provide the national food security, resilience to the coastal community, and others so on. And at the same time, our coastal ecosystem could able to mitigate greenhouse gases. In this term, we call it as a blue carbon. This is figure telling us about how big Indonesia is and how marine biodiversity is located in the heart of the Indonesia. I think in the left side, you can see here the map of Indonesia in the distribution of coral reef, and below is the mangrove, and then on the top, on the bottom is seagrass distribution. So this is give us many important ecosystem services not only for mitigation of climate change adaptation, but also give us some economic value, which is we call it as the blue economy. Then, yeah, for tourism and others so on that can be have sustained our livelihood, especially for the coastal community in Indonesia. Previously, I mentioned about the blue carbon. Maybe some of you not don't know what is the blue carbon means. Blue carbon is, by short explanation, is something like uptaken captured CO2 from the environment, atmosphere or the water column through the photosynthesis process, then accumulated as the biomass. This process, biomass, is included in the mangrove, seagrass, seaweed, phytoplankton, and then they are end up into sediment. A bit some what we call it the carbon dynamic in the coastal vegetation. Maybe some of you need to know, but what is the meaning of the sequestration? This is familiar terminology that for the climate change issue. Sequestration means the the plant or the could able to absorb the CO2 from the environment to their body, and then storage means the CO2 already inside their this is the body or the leaf or stem of branches of the plants, and then release means if someone destroyed or the natural accident could what we call it destroy the ecosystem, and then the CO2 that already stored in their sediment or their body could release to the atmosphere. This is what happened in the number terminology change in the coastal ecosystem. So how the good is our coastal ecosystem? How efficient our coastal ecosystem for carbon sequestration? On the left side, this is the some study by McLennan conducting early 2010, something like that, mentioned about the difference between tropical forest and then coastal ecosystem in mangrove and seagrass and tidal marshes. So it's very big difference. And as well for the annual carbon burial rate, also we have some difference. It's very significant between terrestrial ecosystem, forest, and then coastal ecosystem. On the right side, this is some study conducted by Indonesian scientists by Rahayu 2019 and then Kusmanitias 2018, also telling us about this issue, how big the concentration of the CO2 being uptake or being stored in the seagrass or mangrove ecosystem in Indonesia. I would like to combine both two explanations. Before, I think we have already some information about the carbon dynamic, that what happened usually in the biomass, what people use up to now measure mostly are the biomass, which is actually is about 20 to 30% of the total carbon in the ecosystem, because most of the carbon they are stored in the root or in the sediment, about 70 to 80%. And this information already proved by many scientists, including our latest publication here, that in the for seagrass ecosystem also, and as well as the mangrove ecosystem, they have similar pattern, that the biomass is only small thing on carbon uptaken compared to what already stored in the sediment. So this is good for when we are doing about negotiation and give some information to the people that that's the important is what is going on the below ground, something like that. This is the fact. How is the blue carbon ecosystem in Indonesia? We summarize it from different paper here, but in general we found that our mangrove ecosystem about 3.3 million hectares. Some people say it's 3.1, some people say 3.4, but it's more than 3 million. And as well as seagrass. And then the carbon storage in the mangrove ecosystem, roughly, this is the again, the mean is about 950 megagram carbon per hectare. In comparison with the seagrass, it's about 119 megagram carbon per hectare being stored. I would like to show you some example of our study some time ago. This is, since we are talking about small islands, this study conducted in a different environment. One is the small island in the Kongsi Island. Maybe some of you know already. Kongsi Island is the a part of the Seribu Island Regency, or 10,000 Island, northern part of Jakarta. And in the other study in the East Kalimantan, and then another in the Segara Anakan Lagung in the central Java. So we can see, first, we would like to show you where is the source of the carbon in this different ecosystem, small island and then in bigger island. So from our tracing through the composition of delta C13 and Cn ratio, we plotted like here. I think maybe you can see here the C13, delta C13 here in the vertical, and then the horizontal line is Cn ratio. This approach are linked with what's already published by Khan in 2018, but by using this kind of composition, we could able to trace where is the source of the particular carbon in that particular area. Here, since we are focusing on the small island here in the Kongsi Island, maybe you can see the green box here, no, the blue box. And then we can identify that most of the organic carbon in the Kongsi Island is mostly coming from the marine phytoplankton or marine POC, particulate organic carbon in the ocean in that area. It's nothing related to any influence of the freshwater as like in another region here. We call it in the Java and then in the Brau. They are strongly influenced by freshwater discharges, which means coming from the river nearby the area.
Sorry, Andreas, but can you wrap up your presentation as the time is
near? Okay, this is the story of the Kongsi Island. And yeah, this is the small island, the interesting one. I think the small island is in the Spermoda Island is telling us the same story as well about the source of the carbon. So they are mostly coming from different source and let's call it the end member, something like that. Most of them are coming from the leaf of the seagrass ecosystem from the seagrass itself. So this is also what we call it from the carbon stock in the seagrass ecosystem in these small islands. What like I'm trying to say here that our small islands are very different source of carbon, organic carbon, compared to our big land. So they are very depending on what is going on in the ecosystem nearby the small island, like the seagrass, because in the small island there is no very limited of the fresh water, so that most of the mangrove ecosystem is not really much exist. So in this kind of information, we could able to say that how important of the seagrass ecosystem for protecting, for mitigating our climate change, not only in that particular area, but also in the bigger framework. And one other thing is that besides this, also there are several ecosystem services, not only for carbon, but also for fishing ground, and also for protecting the coastal ecosystem from something like current, something like that. I think this is what we can share through all of you about what's the role of the coastal vegetation for mitigating climate change in the framework for the mangrove and seagrass ecosystem. Thank you, Bu Intan.
Thank you, Pak Andreas. Thank you so much for it's very enlightening. It's very also scientific, triggering on reminding us what's the role of coastal vegetation for mitigation, ya Pak. And we have to remember that Indonesia is so rich. We have the largest mangrove ecosystem, as Pa Andreas reminding us. So we have triggering us. I'm sure many people will be interested more in the scientific dynamics and the use of isotope geochemistry to trace the source of organic materials. And Andreas highlighted that small islands is very different than the big main islands. So therefore, if we want to have more roles in mitigating carbon through our ecosystems, then we also have to pay attention to these big islands. Thank you, Andreas. Those are very inclusive discussions. And I know you might be going soon to catch your flight. So I asked the viewers to have questions that maybe we can fit in before you leave. And there is one question related to blue carbon from Pak Sunario and Pak Sunario Muhtar, and I hope you can answer it before we leave you. So he says that he commented that blue carbon maybe should not be called blue carbon because it's mangrove. If it's mangrove, it should be green carbon. So maybe because you're an expert on this whole blue carbon history, you can remind us why we call this blue carbon. And also the fact that blue carbon, oh, I'm losing, where's the question? Sorry. Yeah, so the process of blue carbon is about mitigating carbon, so that we should remember the end product is not just in the trees, but the one is deposited in the sediment. But maybe you can give us some brief history, why it's called blue carbon, and what do people feel about blue carbon as a role of mitigations globally right now?
Basically, what is mentioned about the blue carbon is we starting in 2009 when the UNEP launching the scientific of the important ocean for the climate change mitigation. In that book produced by UNEP, they have 3 different carbon type, just to make it, actually carbon is black anyway, just to make it people in easy way to understand just by the color. So brown or black carbon is representing the carbon already in the ocean, in the atmosphere, and then green carbon from the terrestrial-based ecosystem, terrestrial forest, and then for mangrove, for blue carbon is for the ocean, the coastal ecosystem in particularly. So the reason for blue carbon, I think for that paper, that book by UNEP is representing that because they found that the most of the mangrove, even though some people say it's a mangrove forest, and also some people say it's a mangrove ecosystem, but nevertheless, it's located in the coastal ecosystem. So people say it's wetland, but not to make it longer. But so this is just a short name for explanation of what is already decided by the UN, UNEP in particular regarding what is the important for different type of color of carbon, something like that.
Yes. Excellent. Thank you, Pa Andreas, for that introduction questions. Naming is important also, but it's also more important what we can do with this action, yes. Right? So, yes. Pa Andreas, just for your information, I'm going to start with the next speaker, but since you're still there, we actually have some questions in the panel discussions. It's in your Zoom panel, and if you could answer them by typing directly to those yes. People who who asked, that would be great. Well, we can move on to the next. But Andreas, thank you so much for your time, and I hope you have a good flight.
Thank you, please. I'm trying to answer. There is many critical questions here.
Thank you so much.
Okay.
Thank you.
Okay, bye.
Yeah, there are excellent questions there, but I have to also give the floor to the next speaker as well. Thank you,
Okay.
Andreas. All right, thank you so much. That was excellent. So next, I would like to introduce Dr. Augie Sahailatua. He is the Director of Research Center for Oceanography of LIPI, Indonesian Institute of Science. He is my boss, actually. His research interest is in fishery oceanography and biology of marine fish, especially pelagic fish. So you can ask him what is pelagic fish there. He is also interested in a study of ichthyoplankton related to marine dynamics. Dr. Augie Sahailatua also involved in several collaborations, such as management of the coastal area in Ambon Bay, flying fish, tuna fishery management, ecology of the living fossil called solocan, ecosystem of Arafura and Timor Sea. So he's an expert in Eastern Indonesia. Ask him a lot of questions here, guys. And he's also been involved in the Triumph collaborative project, which is about Indonesians. So without further ado, Pak Augie, the time is yours.
Thank you, Ibu Intan. It's my pleasure to be here, and good morning, everyone. Good afternoon and good evening, probably for someone in Europe or US, probably with us today. First of all, I would like to thank CAIPSDCC, Griffith University, University Indonesia, and also Hasanuddin University for allowing me to share some of my works and experience on doing research in fisheries. So my question to answer is, are there any effects on pandemic and climate crisis on fisheries? To answer this question, I would like to give my talk in 5 parts. So first, I would like to talk on the recruitment concept, and then I would like to highlight 2 previous studies from myself and colleagues, and what we learned from the study or from my experience so far, and what the scenario for the future, and end up by conclusion, hopefully to answer the question. So to understand the recruitment concept in fishery, please see a life cycle of fish. Most of fish have at least 4 stages in their lives: egg, larvae, juvenile, and adult. So the high mortality rates occurs during the egg and larva stages due to swimming ability and finding food and feeding ability. Therefore, the condition of larva fish determines its ability to survive and affect recruitment and fishery. It means the condition of larva fish determine the stock of fishery. This is a very important thing to understand for fishery management. Because larva fish need food, so nutrients are crucial for survival of fish at larva stage. Nutrients can enhance primary production and the zooplankton, and larva fish need a zooplankton as food. It means that climate probably not affect directly to fishery, but may affect on nutrient cycle, primary production, and zooplankton abundance. My first case study is tuna fishery. In Indonesia, there are 4 main tuna area. Tuna fishing area. So Western Sumatra, South Java, and Nusa Tenggara, Banda Sea, and Papua. My case study is in Banda Sea. But before we see the results, please see this table. This table shows temperature range for tuna habitat. It means tuna could tolerate wide range of temperature, except for southern bluefin tuna. So tuna probably survive well if temperatures slowly change for quite long period. This is why structure of skipjack tuna caught by pool and line in central Maluku, and from 1984 to 2011 show no significant difference in average. If you see the size of 40 centimeter fork length as an adult skipjack tuna, so from 1984 to 2011, most of the catch of skipjack tuna in this area are dominated by adult one. The size is more than 40 centimeters in fork length. However, the study of skipjack tuna in Central Pacific, they made a projection up to 2090, it's another 70 years from now. You can see that decreased biomass could be happen in Western Central Pacific associated with sea surface temperature overheating and increased biomass in Eastern Pacific. So this is probably a challenge faced by the Pacific Island countries and territories in their EEZ. So my second case study is coastal fishery. So this is Ambon Bay. There has two parts, inner and outer bay. Inner bay is smaller than outer bay, and also inner is smaller than outer. Our samples had been taken in 3 executive periods. We had done monthly samples in every period. Period 1 in 1996, 1997. Period 2, 2005, 2006, and period 3 was in 2011, 2012. The average weight of our sample was ranging from 1 to 3 kilograms. So we collected more than 300 fish species belonging to 64 family. Some species are commercial species. And similarity index show no strong similarity among periods. So it means fish species change from P1 to P2 and to P3. So we speculate that it could be happen because of sedimentation in the bay. You could see the area of sedimentation was about 72 hectares in 1994. But in 2012, it was almost double, 138 hectares. We also have information on water quality based on the satellite images. It's done by Professor Sam Hutahaean. Thank you, Pasam. In general, they show water quality change after 1991. So from 1971 to 1991, the condition was oligotropic. And then from this image, we can see since 2006, the condition tend to be mesotropic. So what we learned, so to understand changing in fisheries, we need serial data and information. And then we have to focus research need to be extended. Not only more study on fishery biology, but also on marine habitat and environment. Intensive research and long-term monitoring need to be conducted on fishery, especially for high demand commercial species like tuna, grouper, scads, and so on. And what are the scenarios for the future? Fisheries research design need to be focused on several topics, such as early life history, fish growth stock population, spawning location, migration pattern, food sources, and so on. Research priority we need to set up for research with big impact. For example, target species, high migratory species, threatened species, and endemic species. And we need to enhance collaborative research and sharing research facility, using research vessels, sailing days, laboratory equipment, using new science approach methods, using big data facility. And to sum up my talk, well, we understand Indonesia territory has dominated by marine water, and marine fishery is very important for national benefit. We have a lot of experience in research and monitoring for fisheries, but we need to shift our approach in research in terms of methodology, technology, maybe modeling, and so on. And to understand the effect of pandemic and climate crisis on fisheries, we have to have database and long-term monitoring system. So thank you very much. That's my sharing for today. Back to Intan. Thank you.
Thank you, Pak Augie. Thank you. Thank you. That was great. It's nice and condensed and very enlightening. And thank you for reminding us. Pak Augie reminded us of but the global as well as local perspective on the role of climate. To larger scale, Pak Augie said that yes, big fishes like tuna that we love to eat are very tolerant to temperature changes, but it doesn't mean that they're not affected by climate change, because nutrient changes with climate change, and that affects primary production, yeah, Pak? And that affects tuna, eventually, big fishes that we love to eat. And this is actually very consistent. Here, IPCC released a special report on ocean and cryospheric change. And one of the points was that there has been a migrations of marine organisms, including fish, from the tropical area towards the pole. And this is happening on the surface and on the deep sea. And we are the equatorial area. So our fish actually going away from us because of the changing in the biophysical processes, exactly what we are talking today. And thank you, Pak Augie, for reminding the need of long-term research, but it's also have to have research priority, target species, and we have to share facilities. So Ibu Amanda at the beginning reminded us that this whole climate change issue, we all need to have active collaborations. And that's also not just in negotiations, but also in the research sector. So thank you for reminding us for that aspect, Pak Augie. Thank you, Pak Augie, but we will keep hold the questions for Pak Augie until the Q&A, because Pak Augie is staying with us till the end, yeah, Pak. So therefore, I will move to Dr. Guillermo Diaz-Pulido, and I will read his biography first. Dr. Guillermo Diaz-Pulido is an associate professor at the School of Environment and Science at Griffith University in Brisbane, Australia. He leads the coral reef algae lab in his university. He is also an adjunct research fellow at the Centers of Excellence for Coral Reef Study. Dr. Diaz-Pulido received his bachelor degree in Colombia and his Ph.D. from the James Cook University in Australia in marine botany. He is a pioneer in the study of physiological and ecological effects of anthropogenic activities in coral reef marine plants. His research on the effects of elevated CO2 on the ecological dynamics between macroalgae and corals and the physiological processes of coral red algae is critical for understanding the impact of ocean acidification and warming on coral reef conservation. So we are we'll be listening more how just warming and ocean acidifications to marine organisms. So with that, I will give the floor to Dr. Diaz-Pulido, who is joining us furthest from Brisbane, Australia. The time is yours.
Thank you, Intan. Can you hear me well?
Yes.
Excellent. Yeah, thanks very much for the warm introduction. And I just wanted to thank the collaborative Australia-Indonesia Program on Sustainable Development and Climate Change for this invitation to talk to you all about some issues facing coral reefs, and also how the climate crisis is affecting these valuable ecosystems, and some of the research that we're doing addressing the effects of climate change on macroalgae, which is the main focus of my research. I'm Guillermo Diaz Polido from the School of Environment and Science, and I'm really excited to be here and to share with you some of the stuff that we've been doing here at Griffith University. So first of all, just making sure that it's working. So first of all, I would like to just bring in here my, my laser pointer. So yeah, just wanted to remind the audience of the importance of coral reefs, why coral reefs are so important. I'm just gonna set up here my timer. Yeah, why they're so important? Well, first of all, they are complex and incredibly diverse ecosystems. They're built by the corals, the calcifying organisms, which are the corals, and also the calcareous algae. There's something between 1 to 9 million species living in these ecosystems, and therefore these are ecosystems of incredible beauty. Coral reefs also provide a number of ecosystem goods. They are highly productive, right? They're linked to incredibly productive fisheries, and they provide habitat to millions of organisms. And also they provide, they act as barriers against cyclones, for example, or tsunamis and so on. So they protect the shoreline from these type of disturbances. They also provide a number of ecosystem services. So for example, more than 500 million people derive their livelihoods from these ecosystems. In Australia, for example, $6.5 billion are derived from reefs. So it is a significant contribution to the economy of the country. And this is particularly via the tourism industry, fisheries, and so on. And lots of people love visiting reefs because they're so interesting and very pretty. So they're wonderful ecosystems. Now, I also wanted to remind the audience that reefs are by no means a simple ecosystem or homogeneous ecosystems. They're actually very complex, very heterogeneous, right? So we heard Andreas talking about, that the Indonesian archipelago here is conformed of more than 17,000 islands. So you could just imagine, the complexity of habitats, geographies, geomorphologies that this archipelago has, and also here Australia. And that really creates opportunities for incredible variability and diversity. So for example, here in the Great Barrier Reef, this is assumed from Google, we have inshore reefs, those reefs very close to shore. And we see this photo here, those ecosystems are dominated by seaweeds, right? Very few corals. Now, on the other hand, we have the outer reefs or the offshore reefs, in which they are, we see very few seaweeds, lots of corals, lots of coralline algae, and so on. So, understanding this variability is quite important when people ask, oh, well, are the reefs dead? Are the reefs alive? Well, we really need to consider where you are in the reef, what sort of type of ecosystem we are talking about. All right, so variability is a very important component or element of reefs. Now, I'd like to spend the next couple of minutes talking about the status of coral reefs and the trends in coral reef decline. So this is some data from Bruno and Salik from 2007. It's a little bit old, but the trends are pretty much the same. So here they've presented data from 1968 through to 2004 in terms of coral cover. right? And you see here the trajectory of decline in these reefs is quite significant, about 1 to 2% decline per year. So you do the maths, what could happen in 20 years time? Well, that's not a very nice picture, right? So the other interesting thing from this paper is that this trend in decline in the Indo-Pacific reefs not only happens in one particular region, right? That's happening throughout the region, right? So for example, we've got data here in the bottom, that's East Indonesia and PNG. We see a sharp decline in coral cover, right? But that not only happens here, it's happening in the Great Barrier Reef as well. That is, it is a relatively well or a pretty well managed reef. Things are changing also in this ecosystem, although it is quite well managed. So this gets us thinking that the sources of decline in reefs must be global phenomena directly associated to global climate change. Now, more recently, these are data from Terry Hughes et al., the 2018 Nature paper, where we assessed the impacts of coral bleaching in the Great Barrier Reef. We contributed the data here for the Southern Great Barrier Reef. But the key point that I want to mention here is the significant decline in coral cover in the Great Barrier Reef, particularly here in the Northern Great Barrier Reef. So the trend, the status of the reefs is not a good one. So definitely coral reefs are in crisis, right? They are declining. There's plenty of evidence supporting this. And one of the key issues driving this decline is coral bleaching. We've heard about coral bleaching throughout the news, in the journals, everywhere. And that's pretty much because the corals cannot tolerate significant increases in sea surface temperature, which is a characteristic of heat waves and global warming and so on. This is again data from Terry Hughes et al., in which he's showing here the extent of mass bleaching of corals during the 2015-2016 coral bleaching event. And you see here that that was a true pantropical event, right? Affected all the reefs in the tropics. Now, more specifically for the Great Barrier Reef, these are again data from the Center of Excellence for Coral Reef Studies. I guess the most concerning thing in regards to coral bleaching is that the frequency of this type of disturbances is increasing dramatically, right? We now see bleaching happening back to back, year after year. Initially, we saw the 2016 mass bleaching event. Then we saw the 2017 bleaching event. Everyone was surprised, couldn't believe it. And then bleaching struck again here this year, early this year. So we're seeing a number of major disturbances, coral disturbances happening very, very often, all triggered by emissions of carbon dioxide to the atmosphere. So the trend is very concerning. So the causes, we cannot forget about the local processes, and Augie was mentioning the importance of local processes in his talk before, and we need to consider the declining water quality. Issues associated with agricultural use are very important because they decline water quality through to eutrophication, increased sediment loads, and so on. Overfishing or overexploitation, in particular of herbivorous fish, is also very important because this been associated to incidents of macroalgal blooms or proliferations in some reefs. Physical destruction, of course, is very important for some particular islands or countries, and also outbreaks of the chronothorn starfish are a source of decline for reefs, at least for the Great Barrier Reef and other areas. But I guess more importantly are the global processes. I've already talked about ocean warming, right? Heat waves. all triggering mass coral bleaching, major source of disturbance. But we also need to talk about sea level rise. And this is particularly critical when reefs are not able to continue to grow at the rate that they've been growing. So if there is something affecting the rate of growth of corals and coralline algae, then sea level rise becomes a major issue. Right, ocean acidification, of course, is one of the other major concerns for the health of the coral reef ecosystems. And here's where we're doing a lot of work in my laboratory at Griffith University. We're looking at the impacts of ocean acidification on the coralline algae. Coralline algae, which we have a photo here of coralline algae, they're extremely important for reefs because they are sort of the cement that glues the reef together. Think about like the corals building, sort of providing the blocks for the reefs to be built. The coralline algae are actually the organisms holding the reef together, cementing the reef. And these coralline algae are extremely sensitive to decline in pH, or to the increases in carbon dioxide and ocean acidification. And that's a major source of concern. Now, there is another dimension to ocean acidification, which is that the increasing carbon dioxide concentrations in seawater can actually trigger, right, or enhance the growth of many fleshy seaweeds. And then we have problems with space competition with algae and so on. I'll talk about that in a minute. So this is just to show you one of the studies that we've conducted earlier, where we've looked at the effects of declining pH on the calcification on one species of coralline algae. We now have built a number of experiments looking at the effects on different species of coralline algae, and trends are very similar, in which we see declines of calcification and ability to grow in many species of coralline algae. And this is particularly concerning for small islands, right? Some islands in the Central Pacific, for example, the shallow reef crests of those reefs are completely dominated by coralline algae, right? This is a photo here of Rose Atoll in American Samoa. This incredible photo where the reef of the rim, the reef crest, is completely dominated by this pink sort of encrusting forms of these gorgeous coralline algae. So if the coralline algae...
Dr. Guillermo, can we...
2 minutes, I'm about to finish. Thank you.
Thank you.
So if the coralline algae are very sensitive to ocean acidification, then these reefs are at risk of not being able to keep up with sea level rise, and then communities, right, living in the small islands would be at risk of cyclones and increased sea level rise. Now, the other aspect is elevated CO2 enhances the growth of macroalgae, and this brings problems in terms of the competition with macroalgae, because if algae grow out of control, right, because of increased CO2, then they might suffocate the corals, contributing to reef degradation. And we're doing a lot of work in this space, but I don't have the time to talk much about it. And this is my last slide. So I just wanted to bring everything that I've said together here with some management remarks. So definitely coral reefs are in crisis, right? And if we want to address the reef crisis, we need to act urgently, right? If we want to protect and manage the world's remaining coral reefs. One of the strategies is to strengthen the local management actions, and there is a great paper here by Darling et al. Discussing some of these issues. The need to strengthen no-take reserves, and in general, any type of management that reduces destructive practices should benefit coral survival and growth, and that should be good. Now, local management actions by themselves are not totally effective against reef decline, right? So definitely we need to address the problem from a global perspective, and we need to reduce carbon dioxide concentrations, emissions to the atmosphere. So I think I'm going to leave it there, and thanks very much for listening. Back to you, Intan.
Thank you so much. That was really interesting. Yes, I'm Dr. Guillermo,
Yes.
right?
I'm here.
saying it right?
Yes.
All right. Thank you so much. That was interesting. And it's particularly relevant to us in Indonesia because we are the center of the coral reef ecosystems. And thank you for reminding us how valuable these ecosystems are, the role, but yet it's so complex. There's like 9 million organisms that can live in these ecosystems. But we have to really realize and sink it in that our coral reef are declining, not just from local aspects like declining water quality, exploitations, destructions, crown of thorn, but also global issues that we need to tackle. We have heard so many times about coral bleaching and also how it relates to marine heat waves. So for many of the viewers, maybe who are not familiar with marine heat wave, so we've heard these events called heat wave on land many times, like what happened in Europe last year, for example. Well, what's happening right now is heat wave is also occurring in the oceans. The IPCC report assessed this quite extensively, that this is an emerging issue in the oceans, that its frequency is getting more frequent, it's getting more intense. In fact, at this point, there is no ocean that has not experienced heat wave. So this is something that we all should keep watching and keep being alert, especially those areas that have rich biodiversity, like Eastern Indonesia. And thank you so much for linking that story of ocean changes, not just warming, but ocean acidification, which is a big issue. And maybe in Indonesia, not so much well studied compared to Australia. And I thought that was interesting how you link it to red algae, and that also affects our ability to adapt to sea level rise. So in the end, thank you for reminding it, but it's not just a whole story of adaptations. This is a story of mitigations. Everybody have to chip in. So thank you so much. That was 10 minutes talks. So everybody's give really excellent talks today. So with that, but Leah, do I move forward with the question then?
Yes, you could move forward for the question and answer session.
Okay, I will do. All right, so for everyone's listening, you can again. I will repeat that if you have questions, please put it in the Q&A box, and if you have question that you want to ask and similar to question that people have asked in the box, you can give a thumbs up. So we know those are high priority questions that we need to pay attention to. So for the first question, because this is about also global climate crisis and the pandemic, which is very unusual right now, many of our viewers wants to know your, I guess now for Pak Ogi and also Pak Dr. Gimo, on what is the new normal will impact, how's the pandemic will impact fisheries to Dr. Augie, and to coral reef. I guess Dr. Grimo will be the best person to answer it. So maybe I will ask to Dr. Augie first. Pak Augie, what do you think this pandemic will impact fishery in Indonesia?
Well, sorry, I couldn't turn on my video.
You should be able now.
Okay, I will. Okay, thank you. Well, what's the pandemic can affect the fishery? Well, it's quite hard to answer it because most of the fishery, its impact is not suddenly, because fish mostly can adapt for their environment. But I have some cases, especially in Ambon Island, when the activity inland is suddenly stopped for a while, and seems like the fish population in the coastal, it's growing, it's coming back, it's abundance. But and then they change again. So but you couldn't see it's only for like 3 or 6 months. The other things I had experienced, it's during tsunami in Aceh, or when the tsunami happened in Aceh. So we came to survey for fisheries in Aceh after 6 months of tsunami. And it seems like the water quality back to normal, everything is fine. The fisheries is normal after 6 months of tsunami. So it's so quick. But again, because probably after tsunami, there's no many activities in the coastal or in the water surrounding Aceh. So then everything is going back very soon. So to answer the question, are there any effect of pandemic? Yes, probably in some area, the fish can coming back close to the coastal because no very much activity, especially because probably people are not going fishing. So and then so I mean, a fishing location or fishing ground probably is coming close to the island. But maybe it's not happen in some areas. So, but it's case by case, because we need to observe for that. This my answer. Thank you. Yeah.
Thank you, Pauki. So yeah, that's really interesting that the pandemic is whatever's happening right now is actually quite similar to another crisis, another disaster, which was tsunami, and we saw that was an ecological rebound during after tsunami, and that's what's happening right now. But of course, this is something that we need to maintain as well. So I guess, thank you, Pak Ogi, for the answers. And I will also ask the questions to Dr. Diaz Pulido. What do you think is the impacts that you've seen, you heard, how the pandemic has been impacting coral reef right now? Are you still with us, or the mute?
Okay. Can you
Okay.
hear me?
Yes, I can.
Look, so I guess that's a very interesting and complex question. Look, and I guess it's probably too early to know, but there are some interesting things that we can discuss at this stage. One is that we've seen reductions of pollution worldwide, right? Carbon dioxide emissions have gone down a bit, right? So now, to what extent we can actually see benefits from that reduction of CO2 emissions at this stage in the reef, in terms of slowing down ocean acidification, or in terms of sort of changing the ecological dynamics of the organisms that live there? I think it is probably, in my opinion, too early to know, but we should expect some easing of some stresses in the reef, right? I guess that's in terms of the ecology and functioning of the reef, right? But I could also comment about how the pandemics has influenced the life of the researchers and the park rangers, that people that monitor and check the health of the reef, because with all, many institutions, many people have been locked down in our homes. We have not been able to continue our routine of monitoring the ecosystems, right? So in many instances, we don't know what's happening at this stage, right? So, but there are also some reports that the tourism operators are filling in those spaces that nature are contributing in recording some data, monitoring some reefs in remote locations. So I guess, yeah, I mean, it is a very complex question. There was a commentary in Science just recently, a couple of weeks ago, from some of the researchers at Griffith University talking about that, right? But it wasn't specifically about coral reefs, but they also talked about that this is a great opportunity to make people change their behavior, right? And potentially sort of to contribute to the solution of the problems. And that's something that, you know, some other panelists could be, you know, more appropriate to talk about that. But there's some discussion globally about potential benefits of that. So back to you, Intan.
Thank you. Thank you. So yes, so core reefs are complex. So how they respond to things are very complex, right?
Exactly.
We've seen reductions, and we are all over the globe. Scientists are experience this difficulty to go in the field. Also in our institute, Dr. Diaz-Pulido, that we quarantine. But it's interesting, the issue that you raised on how this whole lockdown will change our carbon budget momentarily or a long-term effects. And I can inform you that right now, IPCC, while preparing for the sixth assessment report, we have started a cross-chapter, a cross-working group discussions to look at this issue. But of course, we also need papers, publications to really assess this, because we do not make new science, right? IPCC compile science. So if you have, would love to, last point was also excellent. This is our chance to change our behavior. We have a momentary rebounds of ecology. Let's keep this momentum. This is maybe a blessing in disguise, maybe. All right, thank you for those excellent answers from Pa Ogi and Dr. Diaz-Pulido. So the next questions, so we want to feel them empowered, right? We want them to leave this forum feeling, what can we do? So, and there are a lot of questions that people ask in the forums. What are practical solutions? Are practical solutions that local people in small islands can do, keeping in mind they want to contribute to climate change adaptation, mitigations, but they need to keep on with their life. They have their economic needs and everything. And they want to, so they ask what are the practical solutions for people, as well as for local management. Dr. Diaz-Pulido, you mentioned about local management. So they want to hear what can they do and perhaps do well. So maybe I'll start, let's switch the order, maybe Dr. Diaz-Pulido first and then Pa Ogi. Still muted? Dr. Diaz-Pulido?
I was muted, yes. So look, thanks very much for that question. That's also a very interesting, but also practical question. Look, you know, that's probably perhaps, you know, it's kind of like a personal question, right? But I guess, you know, we could do a lot of things, right? We know what the problems are, right? We've known the problems for many, many years. The key problem facing reefs is global climate change, right? Ocean warming. That's the major problem, right? So we need to do something about it. What's the problem? Emissions of carbon dioxide to the atmosphere, right? What can we do about it? That sounds like a gigantic problem to address, right? And I'm not gonna dictate, you know, what specifically people have to do, you know, about that. But I think we all know, right? Potentially drive less our cars, potentially travel less, do, you know, less traveling, eat less of, you know, of some type of foods, eat more local. So a lot of behavioral changes again, right? But that you really need to consider the culture of the different people, right? Some people have been living like that for thousands and thousands of years, so we cannot just say, well, change your behavior, right? So it is a very complex issue, right? So if we want to address global climate change, we really need to get into that, right? Now there are, as we've been discussing here, there are local issues here. I guess the local stressors are much easier to manage, I guess, right? Eutrophication, right? Declining water quality. That's something we can do about it. That's something that governments can do about it, right? I'm not gonna list what needs to be done there, but it's manage water quality issues, right? Overexploitation, right? Reduce destructive fishing practices, right? And we know which ones they are. So it's a lot of things that we could do at the local scale, addressing local problems. So, but it is a great question, and I'm sure Augie has many other insights in this regard.
Thank you. Thank you for your answer. So yeah, it's back to also, but every place is of course is different. So I'll give also the time to Pa Ogi to answer that question. Practical solution for local people and local management authority, and maybe during the pandemics as well.
Well, I think Dr. Guillermo already mentioned several things, but I would like to add probably in my fisheries perspective. For example, if you see my presentation, you remember that for like 40 years, fishery using pull and line um, never changed the size, structure, or skipjack tuna. It's mean like it's very friendly technology, fishing technology. So this is just one example. So it's mean like in terms of fishery, probably local people should develop the friendly fishing gear that they use uh, uh, so far, and or if they use the destroying gear or something like that, and then probably they have to avoid or never use again. So because for local people in small island, I think the resources it's very limited. They have to keep the coastal area. It's not just coastal, but also terrestrial, because so everything is every connection. So I mean, using friendly technology or friendly fishing technology could be helped to reduce the impact of climate and also pandemic, I think. So that's the point from my experience. Thank you. Okay.
Thank you, Pa
Okay.
Ogi. And perhaps technology is not just modern technology, but maybe also the, in Indonesia there are many fishing. So I guess it's a good reminder to act locally and think globally on this issue. Yes, thank you. So the next question is for Dr. Diaz-Pulido. So we mentioned how we are having difficulty to monitor the coral reef, the impact of climate change to corals during the pandemic. Do you have any insight? One of our viewers insights on online ways to monitor coral reef while we are on lockdown. Maybe you have some tips.
Thanks for the question to one of the participants. Look, personally, we're not involved in remote monitoring of coral reefs, but I know there are people that are using remote sort of sensors to monitor, right, the condition of the benthos, right, of the reef, and that can be sort of monitored through a network, for example. So you could do that. If you set up sort of underwater cameras, for example, that to continuously to record what's happening in the benthos, and then you use that information with AI technology to sort of quantify fish, measuring size, or measuring changes in whatever you're measuring. That could be a way to go. I think satellite images could potentially also be very helpful, although I don't know whether they would be sensitive enough, right, or the grain would be good enough to uh, do the monitoring that is required to detect changes, right? Because sometimes the changes in the reef sort of composition or reef health are very subtle, right? And so changes in health, for example, of the coral, or sublethal effects, right? Changes in some aspects of the physiology or the microbial communities associated to the organisms, the corals or the algae, won't be picked up very easily, by these technologies. We're still, in the early stages of that. So, I mean, direct sample collection and monitoring is still fundamental, but I know there are a lot of people developing, using robotics and things to monitor change in the oceans. But I think we are still in the early stages here. And it is just challenging times, I think. But hopefully people working in this space could come up with some, innovative ideas on how to sort of monitor or continue to monitor reefs under these circumstances remotely. So, yeah. Back to you, Intan.
Thank you. Excellent. Yes. So this is probably also a good opportunity for us to think outside the box, right, on how we monitor the environment. We used to go out routinely, and this is a good time to start collaborating with other scientists. So this momentum to expand how we do research. So thank you for that reminding environments during the pandemic. Okay, so the next questions I will ask to Pa Ogi. Pa Ogi also have experience working locally in Ambon Bay, which is a very contained area. So nutrient up to some points is important to marine organisms, but once we hit that levels of comfortable, it becomes dangerous. So one of our viewers also want to hear your insights on this, on the aspects on this, and also what they can do to stop having eutrophications. Pak Ogi.
Sorry, I couldn't hear well your question or statement.
Okay.
Can you try again?
So this is about nutrient changes. So nutrient is something that we own, but it also becomes dangerous if we have too many nutrients. So it becomes eutrophication, for example. So one of our viewers want to know how we can control it locally on this issue. What you're very good with listing targeted issue, right? So what can we do to start controlling nutrients, especially, maybe with your experience with Ambon Bay, with something that's very localized, quite in close area?
Well, when I did my, we can call Ambon Bay management in 2010, 2011, and we had is a lot of discussion with the local government there. We always put notification for them if it's is a is an endangered situation, or is marine quality is bad or good. But again, because sometimes it's in my experience, we uh, should be very careful to put some environmental issues to the public, because um, um, so everyone has a different opinion or something like that. Um, and in one case, I have to talk directly to like mayor of Ambon or parliament members to make they understand about the situation before we release to the public. Otherwise, it could be counterproductive in the issue. For example, in Ambon Bay, we have algal bloom, harmful algal bloom uh, event, mostly every year during the southeast monsoon. Um, and and well, scientists from LIPI always monitor the quality or the abundance of the algae, just to well, it's just for scientific reason, but also to help the local government about how to mitigate or the situation. Because uh, once you have like algal bloom in area like Ambon, you couldn't clean up the area. They still live there. Um, it's like virus or something like that. So it's very hard to eliminate or to let the algae down or something like that. So working with the local government, it's very important, and make they understand the situation, because sometimes local government, um, they have a power, but they don't understand something uh, could be in danger in the area. So that's my experience. But I have is one adding information, because Professor JJ asked me about the why it's a love of fish. I mean, determine recruitment on fisheries, not eggs. Because I talk on the wild fishery, it's not aquaculture. In aquaculture, we can control the egg and larva. But in wild, it's very hard to get egg in the wild. At least you have to know the spawning location of the fish. But most study on fisheries, they study on larval fish condition to determine the recruitment on fisheries. So the point is, because in the wild we couldn't control. In aquaculture system, we can control. That's only the point. Thank you. Yeah.
Thank you, Pak Ogi.
Yeah.
Thank you, Pak Ogi. Yes, so Pak Ogi highlight the importance. This is not just the issue for the local people, for scientists to work on, but in the end, we need a top-down regulations. And we know that in this forum, there are many people who are working with the government. So this is our chance to make a difference. We have to have in the end regulations. And Pak Ogi also reminded us that for the speakers, there are actually many questions on the panel of Q&A that we are not going to answer live. We don't have enough time for that, but I would encourage Pak Ogi and Dr. Rias Pulido to answer by typing on the panel. That would be great. There are many excellent questions there. But with that, I will end the Q&A. But before that, I would want to ask each of you to give a closing comments, a take-home message for all of our viewers from these important sessions. So maybe I'll start with Pak Ogi since your mic is still on.
Thank you, Dr. Intan. Well, I can say that climate crisis and pandemic or anything about crisis could be effect to many things. In terms of fishery and well, and my experience for the last 30 years, so we, especially for Indonesia, we have to have a good database and long-term monitoring system because, for example, in Indonesia, we have 108 faculty of fisheries and marine science. It's from west to the east and from north to the south. So there's a lot. We have a lot of marine scientists basically to work together. So work together is very important to develop marine fisheries in Indonesia. Thank you.
Thank you for that encouraging comments, last comment, right? Because we have
100.
strength, we have weakness. So let's use our strength to fill up our weakness, which is monitoring data. Excellent. Thank you, Paugi. I will also now jump to Dr. Diaz Pulido for your closing remark, take-home message for all of our viewers. It's still muted again. Okay.
Yeah, sorry about that. Thank you for the opportunity to comment again. Look, I think, you know, you guys, I mean, Indonesians are blessed, totally blessed, and they're very lucky because you guys have some, if not the best, coral reef ecosystems in the world, right? The most, and one of the speakers, Andreas showed us how the coral reef triangle concentrates the highest diversity of coral species, of mangrove species, of seagrass species. So the Indonesians are totally blessed by that opportunity, right? So embrace that. You guys are very lucky. And so that's one thing that I really wanted to do. And for us, for Griffith University, for the Griffith University side, this is, you know, this creates a great opportunity for us to collaborate, to strengthening our collaborations between our institutions, between our scientists, between the people concerning about the global climate crisis. So I think these kind of spaces are very good for us to share knowledge, to share you know, the thinking. So that's really great. Another closing remark here is that we definitely need to think both locally and globally if we want to sort out the problems, right? So, I mean, these problems, the global climate change problems, look gigantic, look very difficult for sort of the normal people to, what can we do, right? Still lots of things we can do, right? We could work with governments, right? The issue that you raised earlier about nutrients, well, and Augie just really was totally correct. We need to work with the governments. Governments need to work with the users, right? The people working the land, the graziers, the growers, right? So it has to be a collaborative approach there between scientists, governments, and people. So we could sort of just get, you know, to the other side of the crisis. So, and yeah, that's, thanks very much.
Thank you, Dr. Diaz Pulido. Thank you for this forum was made possible because of the initiations of collaborations between Griffith, UI, and UNHAS. And it's important to also remind ourselves that collaborations doesn't stop with the pandemic, right? We can connect like this. I can talk to people in Brisbane, everybody connects. us from collaborating. In fact, it should strengthen our collaboration and supporting each other's comments as a takeaway. So with that, I will close the Q&A questions. Thank you so much for excellent presentations, excellent answers, and take-home message. I will give the floor back to you, Mbak Lia. Thank you.
Thank you very much, Dr. Intan. That's a very wonderful sharing you have done. So thank you again. And then also thank you for all the great panelists for the very useful insight. Ibu Amanda, Dr. Ogi, and Dr. GMO. So I think we have a really good discussion, and we have tried to answer some of these questions, the most relevant and most favorite one. Apology for those who cannot be answered the question. Hopefully next time we can meet again, or you can also contact the speaker directly. You can later ask us about their contact if you need to, I don't know, initiate research collaboration, for example, with your universities. So now I would like to share the result of the polling. 100% of the participants have participated in the polling, so that's great. Thank you very much. So if you can see at the polling section over there, and you can see the result, and I will share also the screen so that the people from watching it from YouTube can also see this. Okay, so it's actually 535 people have joined, but I've just screenshotted like a few minutes ago, so there's a discrepancy in numbers. So, but I think it's still a good number. Out of those who forwarded, 27% of them are from national government, 8% from local government, 40% from academia, 21% from student, 4% private sector, 6% NGO, 6% community, and 1% media. We go to the first question. What is perceived as the major cause of coral reef decline in your region? Over 30% people said it's because of overfishing, 35% said because of declining water quality, 49% because of climate change, and 43% because of physical destruction. So this is a question from Dr. GMO. And then question number 2, what do you think of the progress of research on fisheries in Indonesia? 9% said it's pretty good, 39% it's okay, 52% still lack of research, hence need more research. So this is a great opportunity for us to improve our research on fisheries. This is question from Dr. Ogi. Next question, what do you think is the most important in the fisheries management? 74% said human resources, 53% said research program, and 45% said research institute infrastructure. I guess I set this question as you people can choose more than one. Apology for that. So that's why it's more than 100%. But you can see like this, the most important thing thought by the participant was because the human resources. And then, okay, so that's the last question. And then I will stop sharing this one. So I hope it can give us some insights into what the participants think about different issues that was asked by the panelists. We will share this result to the panelists, and then hopefully it can help with our understanding of the public opinion or the participants' opinion, at least. We have more than 500 here, so I guess it will help in your getting insight for maybe your next research. So, ladies and gentlemen, I guess we are reaching the end of this webinar, and I would like to test whether Prof. Yatna Supriyatna is still here. Prof. Yatna Supriyatna is the Director of Institute for Sustainable Earth and Resources in Universitas Indonesia, and he's been chairing this CAIPSDCC as well, together with Prof. Kathleen Byrne from Griffith University. I guess Prof. Yatna is not here with us anymore, so I think I can end this webinar by also saying thank you, huge thank you for all the panelists, and then the chair, and then also mostly the participants who have joined us until the end of this webinar. more than 500 of you, and also from YouTube more than 100 as well. So in total, maybe we have around 700. And then the YouTube live session will be recorded later, and then you can access it again in the future. So feel free to rewatch that again or share it to your contacts. So by that, I would also like to remind the participants, if you would like to download the materials, you can access it through our Google Drive link that was posted in the Facebook page of Institute for Sustainable Earth and Resources. So you can find that one out.
May I share the screen now?
Oh, yes, yes. Handika, I make you the host so you can share the screen. And yeah, and then for those of you who wants to get certificate, you could fill in the form that has sent by Handika, I think in the chat box, and also here in the screen. We have a time limit. We wait until 10 past 12 so that we can ensure that people who request for certificates are the one who is joining this webinar. So again, thank you very much. We will stay here for a little while so that the participants can take a note on that one. But I would like to say again, huge thank you for all the panelists. So hopefully I can meet you again, both online or directly face to face. Maybe Dr. Guillermo, if I come to Brisbane sometime, we'll see you there. Okay, then. Thank you very much again. Bye-bye. See you next week. Oh, yeah. About next week, we will talk about the community and the small island facing multiple crises. So stay tuned. Same time, I guess 10:30. Yeah, 10:30 a.m. Jakarta, 1:30 p.m. Brisbane for next week. We will send out the information soon in your email or in our Facebook page. So bye-bye. See you next week.
Bye.
Thank you, Malia. Thank you.
Thank you.
Bye.
Kak Ogi, makasih. Dr. Intan, makasih. Thank you.
Thank you.
Dr. Guillermo.
Thank
Terima kasih
you.
banyak.
Amanda.
Thank
Prof.
you.
Yana, bye.
Bye.
It's excellent. I hope you all enjoy it.
That was fun. Yeah.
Okay, you can leave the webinar if you wish. We still wait for a while for the participants to take notes. Yeah. Oh, hope it was great that Dr. Intan's connection was good, yeah.
Oh, yes.
There was a bit of hiccup, but yes.
All right, Leah.
Yes.
There are lots of questions in the chat in the Q&A, but I have to leave.
Yeah,
I have
it's fine.
to go.
Yes,
so
it's fine.
Unfortunately, there's some really interesting questions there, but I won't be able to answer them now.
Yeah.
So I guess if the participants are interested, they could just get in touch through us via either our Twitter account or email. That would be great. But might have to leave very, very soon.
Yeah, that's totally fine. Thank you very much for your time.
Thank you, Leah. Thank you, Dr. Augie. Nice meeting you.
Thank you. Thank you.
Thank you.
And thanks very much. And, say hello to Professor Jamaluddin Jompa.
Yes.
I know he's very close to some of you. So see you later. Bye-bye.
Bye.
Bye.
I'm leaving. So thank you, everyone. I'm leaving.
Yeah.
Okay.
Thank you, Pak Ogi.
Terima kasih
Hendika,
semua.
stop live streaming YouTube, please.
Saya live ya, Mbak ya.
Ya, makasih banyak.
Sehat semua.
You're doing a great job. Thank you.
Oh, thank you. Thank you.
Live-nya sudah stop kah?
Dikasih waktu 2 menit lagi aja kali ya, Miss ya.
Oh, yang YouTube. Okay. So that they can see you, right? Okay, the participants can leave if you wish. That's fine. If you have noted that. Terima kasih ya sudah join hingga akhir. Oke. Danen. Hey, Cam. Oh, Kimberly, my friend from the Philippines. It's good to know that you're joining.